Write down the Taylor series expansion of the function log x about x equal to 1 up to 3 non-zero terms for x greater than 0. Taylor series. This solution, let f of x equal to log of x, then the Taylor series at x equal to 1, f of x equal to log x, f of 1 x equal 1 equal to log 1 value is 0, log 1 equal to 0, log 1 value is 0. Next, f dash derivative with respect to x, f of x derivative f dash x, log x derivative 1 by x, this is f of 1 equal to 1 by 1 equal to 1. This converted to f double dash x equal to minus 1 by x square. F of 1, f of dash, f double dash 1 equal to minus 1 by 1 whole square equal to minus 1. This is derivative of 1 by x equal to minus 1 by x square. Next is f double dash, f triple dash x equal to minus 1. And this value is minus 2. This value is minus 2. Minus 1 plus 2. Plus 2 by x cube equal to f double triple dash 1 equal to 2 by 1 whole cube equal to 2. Next, f fourth derivative equal to this minus. Simple technique. This is a 3 power. The numerator minus 2. Minus 3. 2 into minus 3 minus 6 by increasing degree 4. Simple. This is a f fourth derivative of 1 equal to minus 6 by 1 power of 4 equal to minus 6. This is a 1 second repeated. Let f of x equal to log x. This is a function. Next, about x equal to 1. Then the Taylor series at x equal to 1. First, f of x equal to log x. The substitution 1. This. F of 1 equal to log 1 equal to 0. Log 1 value is 0. Next, log x derivative with respect to x. F of x derivative f dash x. Log x derivative 1 by x equal to f dash 1 equal to 1 by 1. X equal to 1 equal to 1. Next, this is 1 into this power a degree is 1. This is numerator minus 1. Plus 1 into minus 1, minus 1. This degree is increasing. Denominator degree is increasing. X square. F double dash equal to derivative of 1 by x equal to minus 1 by x square. F double dash 1 equal to minus 1 by 1 whole square equal to minus 1. Next, F triple dash minus 1. This is a degree numerator. 2 degrees numerator minus 1 minus 2 equal to plus 2. They increase in degree x cube. F triple dash 1 equal to 2 by 1 whole cube equal to 2. Next, 2 into the degree is numerator minus 3 2 into minus 3 minus 6. Decreasing, increasing x for 4. F fourth derivative of x equal to minus 6 x for 4 equal to f dash fourth 1 minus 6 by 1 power 4 equal to minus 6. Taylor series expansion of f of x equal to f of a f dash a by 1 factorial into x minus a plus f double dash a in by 2 factor into x minus a whole square f triple dash a by 3 factor into x minus a whole cube plus f 4 dash a fourth derivative 4 factor into x minus a whole cube plus so on. This Taylor series expansion of f of x equal to f of a plus f dash a by 1 factor into x minus a plus f double dash a by 2 factor into x minus a whole square plus f triple dash a by 3 factor into x minus a whole cube plus f fourth derivative of a by 4 factor into x minus a power of 4 plus dash. This value x equal to 1, x equal to 1 or a equal to 1, a equal to 1. F of x equal to log x, f of 1 value 0 plus f of a1 dash value is 1 by 1 factorial into x minus 1 plus f double dash value is minus 1 by 2 factor into x minus 1 whole square. F triple dash a equal to 2 by 3 factor into x minus 1 whole cube plus f fourth derivative minus 6 by 4 factor into x minus 1 power of 4 plus dash. This is a 0. This is a 1 factor into 1 x minus 1 minus 1 factor x minus 1 whole square by 2. Next equal 2 by 2 6 3 factor into 6 into x minus 1 whole cube minus 6 4 factorial 24. 4 factor means equal to 1 into 2 into 3 into 4 12 into 24 24 x minus 4 1 power of 4 plus dash. This 6 1 ja 6 4 ja 2 1 ja 2 3 ja equal to log x equal to x minus 1 minus x minus 1 whole square by 2 plus 1 by 3 into x minus 1 whole cube minus 1 by 4 into x minus 1 power of 4 dash. This by 1. This is Taylor log x expansion Taylor series. Third problem. Expand sign in increasing power x minus pi by 4 up to 3 non-zero terms. This is not a mention. This is a Maclaus series problem also. This sin x, cos square x, tan inverse log of 1 minus x, log of 1 plus. This is a use the Taylor series. This solution is let f of x equal to sin x. Then the Taylor series expansion of x equal to pi by 4 at x equal to pi by 4 expansion. This is a f of x equal to sin x implies sin of pi by 4 equal to sin pi by 4. Sin pi by 4 value is 1 by root 2. And out 1 by root 2. Next, with respect, this is a f of x equal to sin x with respect to derivative with respect to x. F of x derivative is f dash x. Sin x derivative is cos x. Cos x. Again, f dash pi by 4 equal to cos of pi by 4 equal to cos pi by 4 equal 1 by root 2. Next, f double dash x sin cos x derivative is minus sin x. Next, f double dash of pi by 4 equal to sin of minus sin of pi by 4 equal to minus 1 by root 2. Next, f triple dash x equal to sin x derivative minus cos sin x derivative cos x. F triple dash pi by 4 equal to minus cos of pi by 4 equal to minus 1 by root 2. Next, the Taylor series expansion. The Taylor series f of x equal to f of a f dash a by 1 factor into x minus a f double dash a by 2 factor into x minus a whole square f triple dash a of 3 factor into x minus a whole cube plus dash. This f of x equal to f of a f dash Taylor series f of x equal to f of a dash by 1 factor into x minus a f double dash a by 2 factor into x minus a f triple dash a by 3 factor into x minus a whole cube plus so on. F of x equal to sin x equal to f of a value is 1 by f of a value is f of a is pi by 4. This is a pi by 4. This is a 5 by 4 x equal to x minus a pi by 4 x equal to 1 by root 2 plus f of 1 by root 2 by 1 factor into x minus pi by 4 plus f double dash equal to minus 1 by root 2 by 2 factorial into x minus pi by 4 whole square plus minus 1 by root 2 by 3 factorial into x minus pi by 4 whole cube plus dash equal to 1 by root 2 plus equal to 1 by root 2 into x minus pi by 4 into 1 factorial minus 1 by 2 into root factorial into root 2 into 2 factorial into x minus pi by 4 1 by root 2 into x minus pi by 4 whole square by 2 factorial minus 1 by root 2 into x minus pi by 4 whole cube by 3 factorial plus dash. This is a 1 by root 2 common 1 plus x minus pi by 4 by 1 factorial minus x minus pi by 4 whole square by 2 factorial minus x minus pi by 4 whole cube by 3 factorial plus so on. This is a equal to root 2 by root 2 multiplication divided. This is a numerator denominator with root 2 into 1 plus x minus pi by 4 by 1 factorial minus x minus pi by 4 whole square by 2 factorial x minus pi by 4 whole cube by 3 factorial plus dash equal to root 2 into root 2 square root 2 by 2 sin x equal to 1 plus x minus pi by 4 by 1 factorial minus x minus pi by 4 whole square by 2 factorial minus x minus pi by 4 whole cube by 3 factorial plus that dash. Expand the polynomial f of x equal to x square minus 3x plus 2 in the power of x minus 1. X equal to 1, x minus 1. This is a solution. Let f of x equal to x cube, x square minus 3x plus 2. Then the Taylor series at x equal to 1. F of x equal to x square minus 3x plus 2. This f of 1 equal to 1 whole square minus 3 into 1 plus 2 equal to 0. 1 plus 2, 3. Minus 3 plus 3, 0. Next, f dash x equal to 2x minus 3. Next, at f dash 1 equal to 2 into 1 minus 3. 2 minus 3 minus 1. F double dash x equal to 2. In the derivative is x derivative 1, 2 into 1, 2, constant derivative 0. F double dash 1 equal to 2. Now, Taylor series expansion at x equal to 1. F of x equal to f of 1 plus f dash 1 by 1 factor into x minus 1 f double dash 1 into 2 factor into x minus 1 whole square plus so on. This f of x, this is a x square minus 3x plus 2. F of 1 value is 0 plus f of 2 value minus 1 by 1 factorial x minus 1 plus f dash 2 by 2 factorial x minus 1 whole square plus dash. This is a 0 minus 1 minus of x minus 1 2 cancel plus x minus 1 whole square plus dash. This is a x square minus 3x plus 2. This is a solution. Expansion. Dear students, limiting function. Limit of function. Let f be the function depend over a deleted neighborhood. What is the neighborhood? Neighborhood set a minus delta comma a plus delta is called the deleted neighborhood. A minus delta, a plus delta is deleted neighborhood. A minus delta comma a is left neighborhood. Is a comma a plus delta is right neighborhood. Neighborhood is NBB. This is a neighborhood set. The neighborhood set is a is a real number, delta is other real number. A minus delta comma a plus delta is called the neighborhood set. This is a minus delta comma a is the left neighborhood. A comma a plus delta is right neighborhood. This is a limit of the function. Let f be the function defined over the deleted neighborhood of the real number a and L be the real number if to every positive number epsilon is small value epsilon there exists positive number. This is the delta. There exists a positive number delta. This is a the smallest is epsilon. Epsilon value, there exists a positive number delta such that mod of f of x minus L less than epsilon for all x such that 0 less than mod of x minus A less than delta. We say that f of x tends to L and x tends to A. We write it is a limit extends to A, f of x equal to L. F of x equal to L. Once again repeated, let f be a function. Let f be a function. Wow. Depend the over neighborhood, related neighborhood of the real number A. Real number A. This is x tends to A. This is A. X tends to A. X tends to A. This is L be the real number. 2. This is limit f of x equal to L. The every positive number epsilon, there exists a positive number delta such that mod of f of x minus L less than epsilon for all x such that 0 less than mod less x minus A less than epsilon. We say that f of x tends to L as x tends to A. With the right, it is a function limit x tends to f of x equal to L. And say the right limit and left limit. Right limit, right hand limits and left hand limits. This is a limit x tends to A plus f of x equal to L. Next, left hand limits. Limits x tends to A minus f of x equal to L. This is a right hand limit. This is a left hand limit. Right, limit x tends to A plus f of x equal to L. Limit x tends to A minus f of x equal to L. This is a function definition. F of x be the function, depend the related neighborhood. This is A comma A plus delta. This neighborhood set, A is the real number and L be the positive real number. There exists delta epsilon the greater than 0. This 0 less than x minus A less than delta. Which tends to limit x tends to A plus f of x equal to L. This is called the right hand limits. This left hand limit is x tends to A minus A f of x equal to L. Right hand limit. F of x be a function defined in the interval A comma A plus h and L be the real number to the every positive number epsilon. Their correspondence the positive number delta such that mod of f of x minus L less than epsilon for all x belongs to A comma A plus delta. Then we say that f of x tends to L as x approaches a through value higher than A. Value higher than. We denote limit x tends to A plus f of x equal to L. Or limit x tends to h tends to plus 0 plus f of A plus h equal to L. This function, the interval, the right hand limit, the intervals, that is their neighborhood. This A plus comma A plus delta. This is a right neighborhood. This delta is h. L be the real number. Every positive number epsilon, this epsilon is a small error value. Their corresponding positive numbers, the epsilon value is a positive value such that mod of f of x minus L less than epsilon. This is a function, f of x is a function, that tends to L mod of less than epsilon for all x belongs to this intervals a comma a plus h or delta. This is a neighborhood, right hand side neighborhood a comma a plus delta. We says f of x tends to L as x tends to approaches the higher values of higher than a. This value we denoted function right hand side function limit x tends to a plus L, f of x equal to L, or limit h tends to 0 plus f of a plus h equal to L. Same left hand and limit function, let f of x be a function. This is a minus h comma a. This interval that define the interval a minus h comma a, L be the first two real numbers if their positive number epsilon such that positive intervals. This is a minus limit x tends to a f of x L. This minus limit f of a plus h equal to L. It is a left hand limit, right hand limit. Or indeterminate form. This form is 0 by 0, infinite by infinity, comma, infinity minus infinity, comma, 0 into infinity, 0 power of 0, infinite power of 0, comma, and 1 power of infinity, 1 power of infinity are called indeterminate form. Indeterminate forms. This is the limits. Suppose example sin x by x. This is a sin x square. This is a limit sin 0 0. This is 0 whole square equal to 0. Infinity form. This is a. This infinity form. This is no solution. This is a L-Hospital, numerator derivative and numerator derivative. This is called the L-Hospital rule. If limit extends to a, f of x by g of x is of the form 0 by 0 and infinity by infinity. This limit function f of x by g of x. This limit extends to a substitution, x-ray plus substitution is a, this a. This form of 0 by 0 or infinity by infinity. Then limit extends to a, f of x by g of x. This limit extends to a, the numerator derivative, separate numerator derivative and denominator derivative. Limit extends to a, f dash x by g of x, g dash of x. Limit extends to a, f dash x by g of g dash x. This is separate derivative. This is a f of x by g of x. This x substitution, this form 0 by 0, infinity by infinity. This numerator derivative, denominator derivative. It is called the L-Hospital rule. Again, this is a limit extends to a, f dash x, f of f dash x, g dash x. Again substitution, limit function. Again 0 by 0, infinity by infinity. Again derivative. This is if limit extends to a, f dash x by g dash x is form of the 0 by 0 or infinity by infinity. Then again the derivative, second derivative. Limit extends to a, f dash x by g of a dash x. Again derivative this also. Limit extends to a, f dash double dash x by g double dash x. Limit extends to a, f double dash x by g double dash x is of the form 0 by 0, infinity by infinity. 1 second, L-Hospital rule. If limit extends to f of x by g of x is of the form 0 by 0 or infinity by infinity, then limit f of x by g of x, limit extends to a, f of x by g of x equal to this function. Suppose limits extends to a, f of a by g of a. This form is 0 by 0 or infinite by infinity. This is a indeterminate form. Indeterminate form. This is a numerator separate derivative, denominator separate derivative. This limit extends to f dash x by g dash x. Separated derivative. Again, this substitution also, f double dash also 0 by 0. If limit extends to a, f dash x by g dash x is of the form 0 by 0 or infinity by infinity, then limit extends to a, f dash x by g dash x equal to, again derivative, numerator derivative, separate, denominator, separate derivative, limit extends to a, f double dash a by g double dash x. This limit extends to a, f double dash x by g double dash x is of the form 0 by 0 or infinity by infinity. Then this can be continued till we finally arrive at a determined result. This is continue derivative 0 by 0, infinity, infinity. This result, this can be continued till we finally arrive at the determined result. Next, limit problems. Example 7.33, page number 26. First, evaluate limit extends to 1. X square minus 3x plus 2 by x square minus 4x plus 3. This is a limit. Solution. Given that limits extends to 1, x square minus 3x plus 2 by x square minus 4x plus 3. This is a x tends to 1 whole square. Substitution first. The limit x to x replaced substitution 1 whole square minus 3 into 1 plus 2 by 1 whole square minus 4 into 1 plus 3 equal to 1 minus 3 plus 2, 0 by 0 form. This 0 by 0 form. This is indeterminate form. This is 0 by 0 or infinity by infinity. Indeterminate. Indeterminate form. Then the L-aspect rule. L-aspect rule is numerator separate derivatives, denominator separate derivative. This is a L-aspect rule. L-aspect rule. Limits extends to 1. X square derivative. For derivative is d by dx of x power of n into x power of n minus 1. d by dx of x equal to 1. This formulas. This x square derivative is 2x minus 3. Constant derivative 0. Constant derivative is 0. X square 2x minus 4. This limit applied. This is a 2 into 1 minus 3, 2 into 1 minus 4 equal to 2 minus 3 and minus 1 by minus 2 equal to 1 by 2. Limits extends to 1, x square minus 3x plus 2 by x square plus 4x plus 3 equal to 1 by 2. This is answer. Any doubts? This is a, explain again. Limit extends to 1, x square minus 3x plus 2 by x square minus 4x plus 3. This given that first step is the x is the substitution. This 1 whole square minus 3 into 1 plus 2 by 1 whole square minus 4 into 1 plus 3. This 1 plus 2 plus 3 minus 3, 0. 1 plus 3, 4. 4 minus 4, 0. This is indeterminate form. 0 by 0 is indeterminate. Indeterminate form is the method is rules is L-aspect rule. This is a L-aspect rule. 0 by 0. This is a indeterminate form. This is the L-aspect rule. L-aspect means numerator derivative, denominator derivative separately. limit x tends to 1, x square derivative is 2x. 3 minus 3 into 1, x derivative 1. X is constant derivative 0. X square derivative 2x minus 4 into x derivative is 1. Constant derivative is 0. This is 1 is substitution. 2 into 1 minus 3. 2 into 1 minus 4. 2 minus 3 minus 1. 2 minus 4 minus 2. Minus into minus plus. Both sides of minus is cancelled. 1 by 2. Then finally results. Limit x tends to 1. X square minus 3x plus 2 by x square minus 4x plus 3 equal to 1 by 2. 7.34 page number 26. Compute the limit. Limit x tends to a x power of n minus a power of n by x minus a. This given that limits x tends to a x power of n minus a power of n by x minus a. Directly substitution. Directly x replaces substitution. This is a power of n minus a power of n by a minus a. The 0 form. This is indeterminate form. This is a indeterminate. 0 by 0 is indeterminate. Is indeterminate form. For this is indeterminate limits x tends to a x power of n minus a power n by x minus a. They use the rule, L'Hospital rule. L'Hospital rule limits x tends to a, numerator separate derivative, denominator separate derivative. This is the x power of n derivative formula. d by dx of x power of n equal to n into x power of n minus 1. This is a derivative of x power of n equal to n into x minus x power of n minus 1. This x power of n. This is a n into x power of n minus 1. This is constant a power of n. A power of nothing, a power of x, not a power of n, 0 by 1 derivative. X derivative is 1. This x derivative is 1. The constant derivative 0. This is a limits x tends to a n power of x minus n minus 1. This a equal substitution equal to n into a power of n minus 1. This is a limits x tends to a x power of n minus a power of n by x minus a. This is a formula. Limit x tends to a x power of n a minus a power of n by x minus a equal to n into a power of n minus 1. This is a formula. Again, the computer limits limit x tends to a x power of n minus a power of n by x minus a. First is directly substitution. First x replace substitution a. X replace a power of n minus a power of n by a minus a. And a power of n minus a power of 0. A minus a 0. This is 0 by 0. Indeterminate form. Indeterminate form is next goes to is the L'Hospital rule. L'Hospital rule is numerator derivative, denominator derivative. Again, x is substitution. Limit x tends to a x power of n formula n into x power of n minus 1. A power of constant 0. X derivative 1. Constant derivative 0. Limit x tends to a n into x power of n minus 1. The substitution x replace a substitution n into a power of n minus 1. This is a final result. This formula limit x tends to a x power of n minus a power of n by x minus a equal to n into a power of n minus 1. This is a formula. 7.35 page number 27. This evaluate the limits. Limit x tends to 0 sin mx by x. This is also formula. This formula is a proof. This is a solution. Given that limits x tends to 0 sin mx by x sin mx. Directly a substitution. This is x replaced sin m into 0 by 0. equal to sin 0 and sin 0 by 0 equal 0 by 0 form. This is indeterminate form. This is a indeterminate. Limit x tends to, given that limit x tends to 0, x replaces to 0, sin m into 0 by 0. M into 0, 0, sin 0 value 0 by 0. 0 by 0 is a indeterminate form. Next, we use the L'Hospital rule. Limits x tends to 0, sin mx by x. This is L'Hospital rule. L'Hospital rule is equal to limits x tends to 0, sin ax, derivative of sin x derivative is cos mx, inner derivative mx derivative m by x equal to limits x tends to a, this constant is beside this m into cos mx by x. X derivative is 1. X derivative is 1. This is a m into limits substitution cos of m into 0 equal to m in cos 0 value 1 equal to m. This is a limit x tends to 0, sin of mx by x equal to m. This limits x tends to 0, sin ax by x equal to a. This formula. Again, explain. Evaluate the limits. Limit x tends to 0, sin mx by x. Given that this is directly substitution x replaced to 0, sin m into 0 by 0, sin into m into 0, 0 by 0, sin 0 value 0 by 0. This is indeterminate form. Indeterminate form is the L'Hospital rule. Limit x tends to sin mx by x, numerator derivative and denominator derivative. Cos sin x derivative cos mx. This is x. This is a x. X inner derivative mx derivative is m. This x derivative is 1. This m constant. This m into limit x tends to cos mx by 1. The directly substitution x replaces substitution is 0. M into cos m into 0. Cos m into 0 cos 0. This is a cos 0 value is 1. M into 1 equal to m. Where m equal to value limit x tends to sin mx by x equal to m. This formula limit x tends to 0, sin x by x equal to a. Example, my dear students, 7.36 page number 27. Evaluate the limits. Limit x tends to 0, sin x by x square. The solution is given that limits x tends to 0, sin of x by x square. This directly substitution. This is a limit x tends to value is sin 0 by 0 whole square, 0 by 0 form. This is a indeterminate form. Indeterminate form. This L'Hospital rule is not applicable. Why? That's positive infinity. This 0 by 0 whole square equal to, evaluate the limit x tends to 0 by 0. This is L'Hospital rule. This is L'Hospital rule. Limits x tends to 0, sin x derivative cos x by 2x is equal to 2 plus cos 0 by 2 into 0. 2 into 2x into 0. Cos 0 value is 1. 1 by 0 equal to infinity. This is a L'Hospital is a RHL. Next, left HL, left and limits equal limits x tends to 0 minus cos of x by into 2x equal cos 0 by 2 into 0 equal 1 by infinity. 1 by 0 equal to minus infinity. Therefore, this is a limit left hand limits does not exist. The right hand limits. Therefore, the limits does not exist. Next example, 7.33, page number 27. If limit theta tends to 0, 1 minus cos m theta by 1 minus cos n theta equal to 1. Then prove that m is equal to plus or minus n. Then prove that m is equal to plus or minus n. Now solution, take the LHS equal to limits theta tends to 0, 1 minus cos m theta by 1 minus cos n theta. Theta replace 0. 1 minus cos m into 0 by 1 minus cos n into 0 equal to 1 minus cos 0 by 1 minus cos 0. 1 minus 1 equal to 0 by 0 form. This is a indeterminate form. This is a indeterminate form. Indeterminate form is L-Aspect rule. L-Aspect rule. L-Aspect rule is limit theta tends to 0, 1 minus cos m theta by 1 minus cos n theta. This is a L-Aspect rule. This numerator, denominator, separative, derivative equal to limits theta tends to 0, 1 derivative is 0, cos derivative minus into minus plus sin m theta. Sin m theta and inner derivative, this is a theta, inner derivative is m by denominator derivative is 0 minus cos n theta. Cos derivative is minus sin theta. Sin n theta. Inner derivative n theta is n equal to m by n. Limits theta tends to 0. Sin m theta by sin n theta. This is this limits this m by n limits x tends to theta tends to 0, sin m theta by sin n theta by theta. This formula is sin limit x tends to 0, sin ax by x equal to a. This formula. Limit x tends to ax by x equal to m by n. This limit theta tends to 0, sin m theta by limits theta tends to 0, sin n theta by theta. This m by n into sin limit x tends to 0, sin ax by x equal to a. This limit theta tends to 0, sin m theta by theta equal to m. By this limit theta tends to 0, sin n theta by theta equal to m square by n square. Limit theta tends to 0, 1 minus cos m theta by 1 minus cos n theta equal to m square by n square. Now the problem is limit tends to 0, 1 minus cos m theta by 1 minus cos n theta equal to 1. This value is m square by n square. This value equal to m square by n square. This is a 1. Cross multiplication, m square equal to n square. M is equal to plus or minus n. Hence, prove. Example 7.38, page number 28. Evaluate limit extends to 1 minus log of 1 minus x by cot of pi x. This is a extends to 1 minus a left limit, left hand side. This solution is limits x tends to 1 minus log of 1 minus x by cot of pi x. This is a one substitution. 1 minus 1 log 1 minus 1 0, log 0 value is infinity. Cot pi value is infinity. This is a infinity form. This is infinity by infinity form. Indeterminate form. This is a indeterminate form. Infinity by infinity. Indeterminate form. Next is L'Hospital rule. L'Hospital rule. Limits x tends to 1 minus log x derivative is 1 by 1 minus x. Again 1 derivative 0 minus x derivative minus 1 by cot x derivative minus cosecant square pi x into inner derivative pi x derivative pi equal to limits x tends to 1 minus equal to minus minus plus equal to 1 by cos, this by 1, this 1 by into pi 1 by pi x equal to 1 minus x by pi into sin square pi. This is limits x tends to 1 minus into 1 by 1 minus x into pi sin square pi x by pi. This limits x tends to 1 minus sin square pi x by pi into 1 minus x, pi into 1 minus x equal to, again limit apply, equal to sin square pi into infinity by 1 minus 1 0, this 0 sin pi 0 by 0 is form, indeterminate form. Again L'Hospital rule applied. This limit x tends to 1 minus, this is x sin pi x n equal to 2 into sin pi x into cos sin x derivative pi x, inner derivative is pi by pi into minus 1 0 minus 1 equal to pi cancel equal limits x tends to minus into minus 2 into sin of pi x into cos of pi x. Limit applied. Limit value is sin pi cos pi equal to minus 2 into sin of 1 into pi into cos of pi equal to 0. Sin cos pi minus 1. Sin pi is 0. 2 into 0, 0. Minus 2. Sin pi value is 1. Cos pi value is 1. This sin pi value is 0. Minus 2 into sin pi cos pi equal to minus 2 into 0 minus 1. Dear students, example 7.39, page number 28. Evaluate limit x tends to 0 plus. 0 plus is right hand limit. 1 by x minus 1 by e power of x minus 1. Solution is given that limits x tends to 0 plus 1 by x minus 1 by e power of x minus 1. First is directly substitution x equal to 0 equal to 1 by 0 minus 1 by e power of 0 minus 1 equal to 1 by 0 minus 1 by 0. Something by 0 equal to infinity. This infinity minus infinity. This form is indeterminate form. Indeterminate form. This is a indeterminate form. Indeterminate form is use the L'Hospital rule. L'Hospital rule limits x tends to 0 plus this 1 by x minus 1 by e power of x minus 1. This limits x tends to 0 plus this LCM is x e power of x minus 1. This x same. This is a x into e power of minus x into 1 into e power of x minus 1 minus e power of x minus 1 e power. That's x into 1 x limits x tends to 0 plus e power of x minus 1 by x e power of x minus x. This is a applied this left x tends to 0 x equal to 0 e power of 0 1 minus 0 minus 1 plus 1 minus 1 cancel is 0 x 0 into e power of x 0 minus is 0 by 0 form. 0 by 0 form is L'Hospital rule. Is L'Hospital rule. L'Hospital rule is L'Hospital rule. L'Hospital rule limits x tends to 0 plus e power of x e power of x minus x minus 1 by x e power of x minus x. L'Hospital rule is applied e power of x to e power of x limits x tends to 0 plus e power of minus 1 by UV formula is x into e power of x plus e power of x minus 1. This again limit applies the e power of 0 equal to 0 by 0 form. Again indeterminate form. Again L'Hospital rule. L'Hospital rule is limits x tends to 0 plus e power of x by x into e power of x UV formula x into e power of x derivative e power of x plus x derivative 1 e power of x plus e power of x is 0 minus 0. Limits x tends to 0 plus e power of x by x e power of x plus 2 e power of x. The limit applied limits x tends to 0 plus equal to e power of x equal to e power of 0 by 0 into e power of 0 plus 2 into e power of 0. E power of 0 value 1. 0 into 1 plus 2 into 1 equal to 1 by 0 plus 2 equal to 1 by 2.